Hello and welcome everyone to the Community Theater. My name is Nathan Walker and I work within Studio. I tell you, I am so excited to talk to you all today about Swift. Yeah, so many new features to walk you through. For example, we can use the super slick AV Audio Engine API to apply a biquadratic filter to live audio. Check it out. Wait, I'm so sorry. I just realized we're not at Worldwide Developers Conference for Apple. How embarrassing. I was so caught up by the news this week. Okay, here we go. Java. Java has been around for years and is such a battle-tested language. Here, we can use Android's audio recorder in Java to generate a waveform and... Oh, geez. This is awkward. Okay, I see now. We're at OpenJS World. JavaScript. Of course, we're here to talk about JavaScript. You know, the amazing thing with JavaScript is we can actually remove the awkwardness in talking about other languages. And it's because we can celebrate things like Swift and Objective-C, Java, and Kotlin, all through JavaScript. In fact, JavaScript can embrace all these languages through their APIs naturally, empowering us as JavaScript developers with high-fidelity platform abilities. This is all made possible by NativeScript and its V8-powered JavaScript engine. Let me ask you, can you see the difference here? You know, besides the title and background color for clarity, there is no difference. This is the very same Swift code driven completely from NativeScript. NativeScript is a JavaScript runtime that allows you to interact with platform APIs entirely in JavaScript with high fidelity. By celebrating platform languages, we can bring together the brilliance, talent, and hard work that all diverse development teams work on every day, without boundaries or hassles. I'd like to discuss natural platform API usage with JavaScript and how the ecosystem can benefit. Let me first define fidelity. It is defined as the degree of exactness with which something is copied or reproduced. In this case, we're talking high fidelity, as in a high degree of exactness. You know, Objective-C, it is a fundamental language providing the base common denominator for the entire iOS platform. This is what we call a platform API. This is just a common example, and it gets the device battery level. You know, when looking at an API like this, how would we learn this platform API? I mean, the answer is probably rather obvious. We would go right to the source from the iOS platform documentation, the creator of this API. We can see here that UI device is a class, which has a static property to current device, and that provides an instance property, battery level. A common pattern with platform API handling from JavaScript is to create an entirely new API to access this natural platform API above. Oftentimes, this involves installing a third-party plugin. How do we know this new API calls the platform API above? Well, because the plugin doc says it does, of course. Do we even care to know what deviceinfo.getBatteryLevel really does on the target platform this runs on? In the short term, surely not. Now, there's good reason to create a new API, or facade, if you will, in this case. It abstracts different language semantics and varied platform API structure from the JavaScript developer. Let's look at a few other examples. React Native has a new JSI architecture. we can learn how to express functions with the C++ programming language to implement a platform API, which doesn't have a JSI plugin available for it yet. For example, here's some C++ code to access that natural platform battery level API. This works. It absolutely does. With Flutter, we can learn the Dart programming language to create a new API as well. For example, using a Dart future alongside a platform.invoke method, which passes along a string representation of an API that exists somewhere. We assume this also eventually calls the battery level API we started with, especially when we run this on the iOS platform. Where would we find out? We could perhaps go look in the source code. I want to make clear, there is nothing wrong with all of these approaches. They work. I am here to discuss natural platform API usage with JavaScript and how the JS ecosystem, including all the approaches just mentioned, can benefit. In discussing some of these examples, we may have forgotten who is the platform. iOS is. Android, Windows, Mac are all the true platforms. For simplicity, we'll focus on iOS here. Of course, iOS is the platform. Really, anything more is further obscuring your ability to understand and work with your true target platform, as well as pivot and adjust to changes in it. All approaches are really solving essentially one thing, at the core of them. Going from one data type to a platform API type and back. In the case of JavaScript, of course, this is, for example, going from a JavaScript string to an NS string and back to a JavaScript string. An NS string representing here the native class that represents strings on the iOS platform. As we often learn the hard way, more infrastructure equals more maintenance. It is inevitable. In the realm of cross-platform work, less really is more. Again, this is the natural platform API documented directly by the API creator. NativeScript just lets you use it naturally. Again, high fidelity is the degree of exactness with which something is copied or reproduced. High fidelity is what NativeScript is all about. This is liberating and leads to development benefits we often take for granted, like just being able to fix a line of code on a whim one day, or enhance a feature without digging through layers and layers of meta that sits on top of our platform. And this is particularly the case when we're talking about layers that go beyond the bounds of our primary programming language. The underpinnings of how this works is made possible from the V8 JavaScript engine we know and love. You may be thinking, this may sound like a data type nightmare waiting to happen. All these non-native JavaScript classes, meaning JavaScript constructs that aren't native to the JavaScript language originally, and all these properties hanging around our code bases for future generations to make sense of. This is a common misconception. This is because NativeScript is fundamentally strongly typed through TypeScript. In fact, you, the developer, have full control of these types at all times. NativeScript has a metadata generator which generates them on demand, meaning you don't have to wait for a maintainer or a third party to use any new platform features to work with their strongly typed characteristics. Which means you seamlessly evolve with the platform. Naturally. Oh, hey, look, a new property, neighbor's device. And what do you know? It was added in iOS 19. Wow. truly, you could access that property the day it's available in the iOS release. Oh, check that out. You could even disable the neighbor's device. Boy, that would be annoying, wouldn't it? So to recap, how do we do less with our infrastructure while still doing more? We say by enriching the language with its own natural abilities. We can do this with V8. Let's talk about how with NativeScript's architecture. NativeScript is comprised of 3 primary sections. The first up and the most fundamental is the metadata generator. It is the key to liberating you individually as the developer. By giving the architecture a self-supporting layer or fidelity to the natural platform API, you are liberated from constantly worrying about a maintainer or third party to do it for you. The metadata generator consists of 3 steps: pre-build, post-build, and link. The pre-build step simply sets up any relevant environment variables. This is, for example, when you're targeting any particular platform. If we're talking iOS, we may think of Intel or ARM64. This is going to set up anything relevant for the build in that environment. Post-build removes the non-valid architectures. Since any library code that we may bring in slices or universal frameworks containing many different supported architectures, post-build makes sure that those are stripped only for the target that we're building for. Link, perhaps the most important, this is where the metadata is generated as a binary file. The binary file gets linked into the app as an object file section. This last part is important. This is actually what avoids the architecture from reading the metadata, parsing and deserializing it from the file system when it needs it. This is really what leads to the incredible performance. All of this allows the app to initialize a V8 isolate with a reference to the metadata. This is what provides the high fidelity link from the platform API to the V8 engine. A key feature of the metadata generator is the ability to transform its output. For example, we can generate TypeScript declarations for our platform anytime with this command, ns typings iOS. This means for a future iOS version, you don't have to wait again for anybody to have access to new platform APIs. You can generate the types against the newer SDK anytime and just use them to strongly type check your project against any new or changed APIs. You maintain control of how your project is managed. For example, here's the output folder containing the platform APIs for the targeted SDK version. This is the AVKit framework, showing some enum structures expressed in TypeScript that would derive from an Objective-C or Swift source. You can mix-match declaration files in your own project in any number of ways that suit you best. The NativeScript TSC maintains types for iOS and Android SDKs via the @nativescript/types npm package. This makes it easy to consume and use them purely as a convenience. These are actually not required, since again, the metadata generator gives you total control. The next piece of NativeScript's architecture that the metadata generator leads to is the platform runtime. V8 is initialized on each target platform. And this is what is published on NPM, for example, NativeScript iOS. The platform runtime is where we use the metadata reference, right here. That runtime configuration is then used to configure and initialize the V8 isolate. The interesting part here is perhaps this line right above. This is where it can take a path to any bundle of JavaScript. In fact, this is why NativeScript can work with any JavaScript stack. The platform runtime takes any JavaScript bundle and allows you to run that naturally in the platform, where all of the platform APIs live naturally. Which brings us to NativeScript Core. This is published on NPM as NativeScript Core. What's interesting to note here is that NativeScript Core is merely an interpretation of what NativeScript's architecture makes possible. It is only one way to implement NativeScript. And it's actually NativeScript Core that leads to developers being able to create rich platform applications with just their JavaScript skills. But if NativeScript enables platform APIs in JavaScript, then don't you have to write platform-specific code? This is another common misconception. NativeScript Core provides consolidated, easy-to-use APIs around the platform APIs NativeScript enables. For example, here's a label class which can be used as a UI component simply called label, which represents a platform UI label on iOS, and a android.text.text view on Android, both constructs which are found from their source documentation. iOS developer docs, you can find plenty of information on UI label. In Android docs, you can find the text view. The battery example we showed earlier is rather trivial, but when we're talking about high fidelity, this stretches all the way through language semantic points, like extending native classes, implementing delegates, passing around functions, multi-threading support, responding to application lifecycle events, and orchestrating complex UI sequences. And hey, look, don't take my word for it. Take a look at these clear examples. Here, we're extending a native class. NSObject is a class that is on the iOS platform naturally. And here we have a JavaScript class which is just extending it. Implementing delegates. What's interesting here is we can actually use TypeScript's implements feature to actually strongly type check that protocol from Objective-C against our JavaScript code. NSURL session task delegate, a very commonly reached for networking class structure on the iOS platform. Passing around functions is particularly amazing to me. That right there, there's a JavaScript fat arrow function, and we can see that we get proper scope closure within a function that is passed to a native platform API. UIView.animate with duration is commonly used throughout iOS for all sorts of animation capabilities. Here we can see the JavaScript scope closure is maintained throughout callbacks that even go seamlessly through to the platform API and JavaScript. We can use powerful platform multi-threading with convenient JavaScript semantics, using workers, of course. What's great about this is this creates a separate and distinct V8 isolate, which runs on its own platform API thread. We can listen to application lifecycle events. For example, that oh-so-handy launch event to handle broad app initialization logic right after the app boots. Oh, and orchestrating complex UI sequences? Yes. Oh, yes. Let me touch on development workflow. The development workflow on a day-to-day basis is provided by the NativeScript CLI. This can be installed via NPM. This allows developers to create iOS and Android apps with their favorite JavaScript front-end stack. By invoking NSCreate, we can give our app a name and choose our favorite JS front-end. We can see we have options from Angular, React, Vue, Svelte, even plain JavaScript, or just a sample TypeScript project. Then there are templates that are set up to help provide examples that you can build on top of or learn from. This creates a ready-to-develop project. There are two primary development actions we can choose. NSRun lets us run on multiple devices, and if we could connect 20 devices to our computer, you can run on all of them at literally the same time. We have seen it done before. NSDebug starts a WebSocket that allows you to debug with Chrome. This is in particular what I use every day. Debugging in Chrome is incredibly effective and efficient, as we all know. Stepping through breakpoints and everything you would expect with the tools is natural and easy to use. When developing your apps, you can set up your machine using the environment docs in the NativeScript docs. This walks you through setting up Node, Xcode, Android Studio, other development relating tooling. This will give you 100% control of every facet of your development. This summer, however, we are excited to announce Preview 2.0. It is a top-to-bottom revamp of NativeScript Playground, which is going into private beta now. This will work with the latest versions of NativeScript and offers an immediate way to begin developing, skipping local environment setup entirely. You can stop by the NativeScript booth here to check it out for yourself. In fact, because of NativeScript's natural abilities with the JavaScript language itself, the new preview will work from development powerhouse StackBlitz. You'll be able to create any front-end flavor, NativeScript-based project, all from StackBlitz, Angular, Vue, React, and Svelte, to name a few. And this offers a really nice editing experience from the web. We can all benefit from this technology because it can work with any JavaScript stack. It really can help make our teams more productive, more diverse, more accepting, and joyful by truly becoming liberated by the rich creativity that the whole of the technology sector has to offer. We say, embrace it all. Please enjoy the high fidelity of V8 and NativeScript for yourself. And again, my name is Nathan Walker, an engineer within Studio and an active TSC member with NativeScript. Thank you for your time and enjoy the conference.